Good morning, good afternoon, and good evening, everyone from around the world. I see we have participants from Africa, Europe, the Middle East, Asia, so far, far away. Welcome everyone to this Systemair How to Expert webinar. Learn how to correctly operate and maintain general ventilation systems in times of COVID-19. A very important topic. Before we introduce our speakers today, I'd like to remind you that all of you are automatically muted. You can use the Q&A function in this WebEx tool to ask questions at any time, and we will answer them at the end of the event. We will also provide you with the presentation slides after this webinar. So, whom are you dealing with today? First of all, I'd like to introduce myself. My name is Morten. I'm Head of Public Affairs at Systemair Group in Sweden, and I'm your host today. Joining me as well is my colleague Andy from the Netherlands. Andy, a warm welcome to you. And then we have our colleague Ralph. Ralph, joining us from Germany. Hi, Ralph.
Hello, Morten. Hello, guys outside. My name is Ralph Berger, company Menerga. Menerga is part from the Systemair Group since more than 7 years. I'm responsible for the technical department, especially the R&D and product management.
And then passing on to my colleague Richard, who is our product area director, Energy Recovery Systems, joining us from Sweden. Hello, Richard. Richard, are you there?
Hello, Morten. Yes,
Hi.
I am.
So a warm welcome also to you. At any time, feel free to connect with us on LinkedIn. Before we commence with the agenda, a little bit about our recommendations. So at Systemair Group, we value correct and precise data throughout all our processes. So everything we are going to tell you today is unbiased and based on facts and agreed recommendations by academia and by respected organizations such as Eurovent, ASHRAE, or comparable bodies. We, of course, also incorporate our 40+ years of experience in this field as one of the world's leading ventilation companies. And we'd also like to remind you, please critically reflect on all the recommendations provided to you in general, because there has been a lot published over the past weeks, a lot of useful things, but also a lot of items that might be a bit questionable. So just critically reflect on it. So what are we going to do today? What can you expect? First of all, I'm starting with a call for action on why a good and healthy indoor air is more essential than ever. Then I'll pass on to my colleague Andy to go into our general recommendations concerning COVID-19. And he'll also have a special focus on the issue of humidity, which many of you asked for. After that, Andy will hand over to Richard, who will focus on rotary wheels in air handling units and a special focus on leakages. Then we'll go to Ralph, and Ralph introduces you closer to the topic of CO2 levels and air filters. And last but not least, I'll take over again with a question-answer session and some conclusions. So much for this. We'll try to do this all within 1 hour. So call for action. Good and healthy indoor air is more essential than ever. To begin with, what is actually the mission of ventilation? So just to refresh your mind, what is our industry working for? Overall, of course, we want to provide a good and healthy indoor climate, which enables people to thrive. Not only people, of course, ventilation is also essential for certain industrial processes. So in order to achieve this mission, correct ventilation is a key. And it's an essential but often overlooked component of the HVAC terminology. Coming to the next essential question here, what is the purpose of ventilation? Overall, of course, ventilation enables us to breathe clean air, to put it in very simple terms. It removes polluted air from the environment. This can be diesel particles, fumes, but also infectious aerosols, and replaces it with a good quality air. This in a nutshell. And then we also understand why is ventilation actually so important. Because you've heard that over and over again. Just to repeat one more time, on average, 90% of our time is spent indoors. And it's proven throughout multiple studies over and over again throughout the past years that a healthy indoor air climate improves our well-being, it reduces sickness levels, and it helps us to perform better at work, in schools, and at leisure. And now for today's times, why is a good, healthy indoor air more essential than ever? Because now more than ever, we need to ensure that we have healthy indoor environments, and improved high levels of ventilation ensure this. So clean air today needs to be provided to indoor spaces, as the indoor air needs to be diluted. If you want to open a restaurant, bar, etc., you need to ensure that you have ventilation. And correct ventilation, with a focus on correct, is a key to achieving this. And here, as you will also see later, we should mind the difference between AC and ventilation. So it is not anymore enough to only recirculate your indoor air with an air conditioner, but we should separate here that air conditioning should always be in combination with ventilation. And that's why we at Systemair motivate all of you, our industry, to strengthen the V. It's part of our new campaign, which is launched today with this webinar. And it's basically motivates you that a good, healthy indoor air is more essential than ever, and that correctly maintained and operated ventilation is a key to achieve that. So everyone, let's strengthen the V together, and let's not ignore this essential part. So much for my call for action on why a good and healthy indoor air is more essential than ever. And now I will pass on to my colleague, Andy, who will go through our hands-on recommendation on COVID-19 and general ventilation systems with a special focus on humidity. Andy, a warm welcome.
Morten, thank you. So I want to introduce a little bit our general ventilation systems recommendations. And then in the last bit of my part of the presentation, I will focus on why humidity level is so important in our recommendations. First of all, if we go to our core recommendations, we have 3 core recommendations identified. The first one is, of course, to maintain your ventilation system good, make sure that it operates correctly and also operates it correctly according to the planned hours. You can do this using the well-established hygienic standards or the operation manual of any ventilation system. The second recommendation is that we have is to optimize the ventilation so that you ensure that you dilute the used air in the building with fresh outdoor air. And the third, which we will explain later on in more detail, is to maintain a certain humidity level. Optimally around the 50%, but at least above the 40%, but also keep in mind, do not exceed the 60%. The recommendations that we have are for general ventilation applications. So if you have specialized operations such as hospitals, laboratories, then always go to the local building recommendations as they are for these type of industries. Our first recommendation is in more detail is to extend your ventilation system's operating time, preferable to 24 hours and every day of the week. If that's not possible or is costing too much energy, you should at least consider to start your ventilation system earlier, let's say 1 hour earlier as the presence of the humans in the building, and keep it running for at least 2 hours longer as people are in the building. I will come back later why that's so important. Then going to the humidity levels for the building. Like we said, and I will explain later after the recommendations why it's so important, but maintain that minimum humidity level in the building. Use the current temperature set point as it is, but try to optimize your controls around that humidity level of around the 50%. You could even consider to lower the room temperature set point a little bit to more easily reach that 40% minimum humidity level. And it makes maybe at the moment not so much sense as I speak about this, but we started our journey to see what the guidelines should be in March when temperatures were much colder, and then it was much harder to reach that 40% relative humidity as it is today when the climates are a little bit warmer and more humid. But for all recommendations, it's always important to keep the temperatures, but also the humidity levels in the comfort zone of people. If you're out of operation hours, so there are no human present anymore in the building, you could even consider to lower the temperature a little bit lower in the building to again more easily reach that minimum level of 40% relative humidity. If the system as it is today cannot reach the recommended humidity, additional humidity control should be added either in the system or maybe use a room humidifier. When having them done, you could optimize the ventilation. If the building is in full use, so all people are present in the building, it is now recommended to optimize the ventilation by increasing the system volume flow rate. So increasing the amount of fresh air that you bring in the building. But keep in mind that you don't interfere with the recommended humidity level. These days, also we notice that of course not all buildings have the full load of people, especially when governments recommend to work as much as possible from home. Then you notice that there is an over amount of air volume. You can use then your CO2 level control, which is in most cases available in the controls of the units, to lower a little bit the air volume. And with lowering the air volume which you bring in from outside, especially when the humidity is dry, it's more easy to keep that humidity level at least at 40%. If you don't have that CO2 level control available in your unit, then at least keep the unit running at a constant airflow so that you ensure the bringing of fresh outdoor air to the building. Then recirculation. Recirculation is basically, like Morten already mentioned, the use of the air which is already polluted by people in the building, like an EC system. If it's possible, during operation hours, switch off the recirculation mode, because then fresh air will be brought to the building again. And if recirculation mode is set on 100% recirculation, no fresh air will come in, and that's of course not recommended at the moment. During non-operation hours, that recirculation mode can be used to keep that humidity level to a higher level from 40 to 60%. So then it could be recommended to use that recirculation mode to maintain a good level of humidity in the building. Like said in the beginning, I will come back later a little bit about why that relative humidity is important these days. And we did a lot of studies, or we read a lot of studies to see what could be recommended to bring good air in the building these days with these viruses. And then we noticed that from a scientific research, that hospital air infections are easier or more happening when the relative humidity is low in hospitals. This research was done with 9 different variables, such as temperature, humidity, and these other type of variables over 300 different patient rooms. And at the end, they gathered around 8 million data points. And there was basically one driver, that relative humidity, that showed that infections happened less when the humidity was above 40%. That's what you also see in the first graph. The blue line is the relative humidity in the room, and the red bars are the infections, or the number of infections in these rooms. And then you see that when the relative humidity is higher, you see those infection rates are lower. So therefore it can be concluded, and it's generally stated, that our personal well-being, or we are healthier when the air is hydrated. Also, with those higher relative humidities, aerosols travel less far. Viruses, also the COVID-19 viruses, are captured in aerosols, and those aerosols travel throughout the air to the next person. Therefore, it's recommended to sneeze in your elbow. Therefore, it's also recommended when you are very close together in a room to use, or in a certain area, to use masks. That's to prevent those aerosols to travel throughout the air. If the humidity in the air is higher, those aerosols are more heavy and will drop down easier to the ground, and therefore not stay in the room's air. From other researches, basically 3 other researches, we noticed, or we learned, that viruses have a decreased survival rate in the air, being an aerosol, if the relative humidity is above 40%. You can see that in the graph on the right bottom, where you should see the viability of the virus in the red line, and then the relative humidity is on the X-bar, and when it's hitting the 40%, you see a significant drop down of the viability of the viruses in the air. So therefore, again, that minimum humidity level of 40% is really important. Also, we learned that viruses can stay much longer alive on surfaces than in the air. And that's what you see in the 5 small graphs at the bottom, where you see that the viruses as aerosols can live up to, depending on the humidity, let's say to 3-4 hours in the air. But if you look to different types of materials, and if we start from the left, you see copper or cardboard, with more important steel and plastic. There you see that the virus can stay much longer alive or viable than in the air. And for these conditions that we show over here, up to 3 days. Other researchers show that if you drop the relative humidity, let's say from this 40%, as the graphs are shown over here, to let's say 20%, the 3 days on steel can go up to 30 days. So less relative humidity increases the viability of a virus also on on surfaces. If you go up, let's say, to 80%, then the viability is a little bit longer again, but still significantly lower as that 20%. But we also have to take in consideration our own comfort zone, which is approximately around the 30 to 60%. So 20 degrees, 40%, the viability of a virus is significantly lower than in dry conditions. And therefore, it's also recommended that by a lot of governments, or by most governments, to clean your working area. You have to clean your handles, your desks, your coffee machines, etc. Because surfaces can be a spread of these viruses. The last two slides were basically why humidity is important in these days of the COVID-19 situation. But basically, we already know for a very long time that indoor humidity level is very improving. It's also part of all the education that we get on school about this subject. We have Dr. Vanger already in the 1930s showing that the human comfort zone, based on the predicted mean vote of a lot of people taking part of this research, that the relative humidity between 30 and 60% is good. It's good for our well-being. And if we are well, we know for sure that things are also really good for our health. Also, we know from scientific research that our respiratory immune system works much better if the relative humidity is higher. The mucus layer, the moist layer in our breathing system, is a little bit thicker, so it holds back more viruses or bacteria. Also, our cilia, the small hairs in our breathing system, are standing up straight and therefore increasing the distance between our body and our respiratory system, so that they cannot penetrate that mucus, that moist layer. Knowing this and looking back to the winter situation, we can now also relate why we then are more vulnerable to those diseases, because during the winter period, the relative humidity is much lower than in the season where we are in right now. In the beginning of this pandemic, it was focused a lot on circulation and ventilation, but more and more associations or well-recognized bodies are promoting this relative humidity. Eurovent, in their technical document concerning COVID-19, states to keep the indoor relative humidity above 30%. This is recently published in the beginning of April. If you look to the UK, the CIBSE, the Chartered Institute of Building Service Engineers, also recommends to keep the relative humidity above 40% when possible. And the ASHRAE, the American Association, also states in their document concerning the COVID-19 that the relative humidity must be or should be above 40% or in between the 40 and 60%. So all with all, and this is the last slide I have, all with all, clean air is only one factor. It's not only about clean air, it's about fresh outdoor air, so that you can dilute the air in the room with the right humidity. And if that humidity is correct, the viability of the viruses in the air will be lower, but also, and very important, also on surfaces, so that the room the next day will be cleaner than the room the day before. and therefore also our recommendation to extend your operation hours much longer than just the hours that people are in the room. Thank you for your attention, and then I give the floor to my colleague Ricard, who will talk about rotary wheels and air handling units. Ricard?
Thank you very much, Andy. This case study is about the rotary heat exchangers and if it should be turned on or off concerning the preferred humidity levels. Our recommendations is to keep the rotor wheel turning, but also remember Systemair core recommendations to set relative humidity control to optimum 50%, minimum 40%, but not exceeding 60%. We have made a practical example to show you why the rotor wheel should be turned on. In the calculation example, we have used 5 different outdoor air conditions with related indoor conditions. The conditions have been calculated in 3 different air handling units, one equipped with sorption rotor, one with condensation rotor, and one with the rotor turned off. In the diagram on the right side, you can follow the relative humidity after the heating and cooling coil in the air handling unit, depending on the outdoor air temperature. As can be seen in the diagram, in case you have a rotor, the additional humidification needed to enter the preferred humidity level is much lower compared to when the rotor is turned off. And if the air handling unit is equipped with a sorption rotor, the additional humidification needed is the lowest around the year. Furthermore, in summer conditions, the sorption rotor dehumidifies the supply air before entering cooling coil, which gives less cooling capacity needed. On the right side, you can find the additional humidification needed. It is calculated to 22 degrees and 40% relative humidity. The dehumidification is calculated to 23 degrees and 60% relative humidity. However, keeping the rotor wheel turning may lead to slightly higher leakage from extract to supply air. Now follows a presentation about the leakage in the rotary heat exchangers. Leakage can occur through sealing, central beam and periphery from one airstream to another. Bypass leakage through sealing in same airstream. Through purge sector. Carryover, that's air carried in storage matrix from one airstream to another. Leakage of casing to and from outside. Eurovent has defined 2 different types of leakages. That's the outdoor air correction factor, OACF, and exhaust air transfer ratio, EATR. OACF is the air going from outdoor to exhaust through sealing and or purge sector. OACF increased exhaust fan power consumption. Here, please note the different naming of the positions at the rotor. 21 outdoor air, 22 supply air, 11 extract air, and 12 exhaust air. EATR is the air going from extract to supply through sealing and or in storage matrix. The air transferred in storage matrix is also called carryover. The leakage is measured with tracer gas, and note only carryover can be influenced by stopping the wheel. In this diagram, you can follow the relation between OACF and EATR. When pressure difference 22 minus 11 increase, the OACF increase and the EATR decrease. It is not possible to reach 0 on both leakages. The purge sector function is to empty the rotor storage mats on extract air, and the purge sector size depends on air velocity. If you have lower air velocity, you need a larger purge sector. Rotation speed, higher RPM, a larger purge sector needed. Pressure difference, less pressure difference, a larger purge sector needed. Matrix thickness, thicker matrix means a larger purge sector needed. In this slide, you can see the leakage influenced by the purge sector. If you increase the pressure difference 22 minus 11, you're getting closer to zero in the EHR, but in the same time, the OECF will increase. And here follows an example on leakage in the rotor when it is included in the air handling unit with different fan positions. The examples come from an outdoor unit, Systemair HH Flex 1206 stacked. The conditions are as follows. On the extract side, the duct system 250 Pascal, inlet 7 Pascal, filter 86 Pascal, and the rotor 157 Pascal. On the supply side, we have the inlet 7 Pascal, filter 117 Pascal, and the rotor 157 Pascal. In all these four examples, we have promised the customer 13,000 cubic meter per hour of fresh air. So let us start with the example on the top left side. In this setup, we have two fans suction the air through the rotor. The pressure difference, 22 minus 11, is 62 Pascal. The unit is equipped with a purge sector, which gives us 1% in EHR leakage. The OACF is 1.05, which will also increase the exhaust fan power consumption. And we need to set the supply fan on 13,130 cubic meter per hour. Now to the top right example. In this setup, we have two fans pushing the air through the rotor. The pressure difference 22 minus 11 is 246 Pascal. The unit is equipped with a purge sector, which gives us 0.1% in EHR leakage. The OACF will increase to 1.09. Due to the fan position, we need to set the supply fan on 14,183 cubic meter per hour. And now to the bottom left example. In this setup, we have the supply fan suction the air through the rotor and the exhaust fan pushing the air through the rotor. In this example, the pressure difference 22 minus 11 is minus 438 Pascal, and we cannot use purge sector. The EHR leakage is calculated to 5%, but please remember that this condition is not tested in Eurovent program for rotors. The OACF is calculated to 0.95. We need to set the supply fan on 14,300 cubic meter per hour. And last example is the bottom right. In this setup, we have the supply fan pushing the air through the rotor and the exhaust fan suction the air through the rotor. The pressure difference, 22 minus 11, is 746 Pascal. The unit is equipped with the purge sector, which gives us 0% in EHR leakage. However, the large pressure difference also creates a large OACF leakage of 1.14. And due to the fan position, we need to set a supply fan of 14,820 cubic meter per hour. The conclusion is that we prefer the top left setup. It has the lowest total leakage and lowest fan power consumption. And reasons for leakage can be wrong pressure difference between supply and extract, poor sealing, non-adaptive sealing, and no purge sector. However, other types of leakage can occur in the air handling unit. The position of outdoor and exhaust air can create contamination. Leakage due to overpressure exhaust to supply if the unit is delivered as a monoblock. The leakage can come from intermediate walls and door panels, cabling and controls due, for example, drilled holes, but also from components such as plate heat exchangers. And please remember that rotor is the most common used energy recovery component in Europe due to the great temperature and humidity efficiency. Furthermore, it has a low freezing risk, small space is needed, and it's available in all sizes. That was all from me, and I will now hand over to Ralph. The floor is yours.
Thank you, Richard. After the previous general informations from Andy and Richard, now some special informations about the air handling unit control system and the air filtering and the corresponding case studies from Systemair. At first, a few notes on the CO2 level and about CO2 control systems. With a CO2 control system, the main task of a ventilation system, the supply of fresh outside air and the remove of harmful substances and also pathogens from the human living room, can be adapted to the needs. On the harmful substances as a result of the presence of people inside the rooms is CO2, which is unfavorable for human well-being. For this, fresh outside air volume flow is adjusted on the CO2 level. If the CO2 level is too high, the outside air volume flow is increased, or it's necessary to increase the outside air volume flow. The CO2 level is measured by special sensors and expressed in parts per million, ppm. The best achievable CO2 level inside the ventilated rooms is 400 ppm. This is the common outdoor level of CO2. Because air handling unit, a ventilation system, is not removing CO2 from the air, it's only changing fresh air by or remove the room air by fresh air. This is the best achievable CO2 level. Often recommended and accepted is an indoor CO2 level between 800 and 1000 ppm. If the CO2 level becomes higher, 1500 ppm, then this can have a negatively impact of the well-being and the performance of the humans. So higher CO2 levels lead to a lack of concentration, to reduced performance, but also to discomfort for the people living and working in the ventilated space, which increases the health risk for these people. Unlike temperature settings, which vary depending on the season, the CO2 level are usually set once during commissioning and are not adjusted by the user or operator day by day. Our hands-on recommendation, depending on the presence of people, the CO2 control system automatically adjusts the outside air volume flow to the required amount. This makes it easier to prevent the indoor air from drying out due to a high proportion of outside air, especially in the cold season. Please remember about what Andy explained about the best conditions in humidity under the effect of viruses and pathogens. With or without a CO2 control system, we recommend to extend the operating times of the ventilation system up to 24/7 operation time for an excellent air quality at all times inside the ventilated rooms. Our expert advice: check if your ventilation system is controlled by an operation time control with a schedule. In most cases, this schedule can be switched off by choosing manual operation mode, and the ventilation can switched by this to continuous operation in manual operation. If manual operation mode is not available or not possible to switch to this, the switch on and switch off times in the schedule can be adjusted. And second, please check if your ventilation system works with a CO2 control system. The CO2 measurement can take place centrally in the extract air duct or locally in the rooms connected to the ventilation systems, like in VAV systems. If your ventilation system is controlled by a CO2 control system, no further action or change of settings is required. According filtration, compared to the state of the art regarding air filtration, there are no further or special recommendations from Systemair under the effect of COVID-19. State of the art is the filtration standard ISO 16890, from 2016, and the standards and recommendations based on this ISO, such as Eurovent 423. Eurovent 423 includes a hands-on table which shows required filtration efficiency can be reached by using different filters or different combination of filters. This is helpful for consultants or planners to select a recommended filtration efficiency depending on outdoor and supply air category. That means depending on the place of installation and depending on the application. There is no need to change the filter quality of the installed ventilation system in your office building or your public building. This filter quality was selected during the planning phase, especially for your ventilation system. It's also not necessary to shorten service interval for changing the filter specified by the manufacturer of the ventilation units. Now I want to hand over back to Morten.
Thank you very much, Ralph. Welcome back, everyone. So we are nearing the end here. We have had a call for action from myself in the beginning, talking you through why good and healthy indoor air is more essential than ever. You have heard from my colleague Andy our general recommendations and why humidity is an important aspect in this respect. We have heard from Richard our recommendations concerning rotary wheels and air handling units, and also a special introduction on leakages. Then just Ralph introduced to the CO2 levels and air filters. So we will go to our question and answer session. At any time, you can submit your questions using the Q&A function in the WebEx online meeting tool, or you can use the hand button if you'd like to say something. So prior to the webinar, in your registration form, you had the possibility to already ask questions. We've also collected the ones now that were asked during the webinar. So the following questions we have already received, and I'll invite back all our panelists again today, which is Andy from Netherlands, our HU specialist, Richard concerning rotaries, Ralph, our general technical director at Menerga and humidity specialist, and we in addition have Mikael Lönnberg, who is our technical, our R&D director from Sweden in the factory. So welcome back, everyone. The first question we'd like to ask here, or which we have received before, what is actually the difference between recirculation and leakage? I would say, Andy, would you like to answer this?
Yes, I will try to answer that, Martin. I think it's a good question. Recirculation is, of course, the use of the air which was already in the room, which is typical for AC system, air conditioning systems, so that you 100% reuse the air in the room. And then you don't get any fresh air in the room. Of course, you can have ventilation systems where the recirculation rate is not 100%, but maybe lower. Let's say 50% to keep the temperature level correct in the room. But then the recirculation rate is quite significant. If we talk about leakages, like what Richard explained, a leakage is something that can happen in the system. It can happen in the duct. It can happen at the end of the system where you have contamination from air streams or leakages in the unit, like Richard explained for the heat recovery wheels. Then that part is significantly lower. It's maybe 1 to 2% of leakage that from air that you get back in the system. I hope that's an answer for the one who asked this.
Thank you very much, Andy. I think that makes it much clearer and for everyone important really to differentiate between these two items because they are not the same. Second question we had received prior to the webinar as well. What should be considered if we or our customer still wants to stop the rotary heat exchanger? Richard, I think this is something for you.
Yes. You need to consider if your system has sufficient heating and cooling capacity without the energy recovery components. But you also need to consider the startup of the rotor and do regular maintenance and keep cleaning mode active. That's what I would say.
Thank you, Richard. Here again for you guys, focus on correct ventilation. So as long as you do it correctly, you're on the right way. Next question here. Can all heat recovery systems transfer moist? I think, Ralph, this is something for you as our humidity expert. Ralph, you have to unmute yourself.
I have an answer, so I can try to answer shortly. A heat recovery system as a regenerative heat exchanger is normally transfer moisture from the outside to the returner or back, depending on the humidity level in both air streams. Depending on the type of the regenerative heat exchanger, like rotary heat exchanger, it's possible to transfer more or less humidity. For special coated rotary heat exchangers or regenerative heat exchanger, it's possible to transfer moisture also without condensation. These are absorption coating on the surface. If you have or if you use an regenerative heat exchanger without any coating, then mostly only condensation processes. If the outside air temperature is lower than the dew point of the return air, only with this condensation process and transfer of humidity from the return air to the fresh air is possible. Plate heat exchanger is a so-called recuperative heat recovery system. Do normally not transfer moisture from the return air to the fresh air, only in a special application as an enthalpy changer with membranes, not aluminium plates as spacers between both air streams. it's possible to transfer moisture from return air to supply air. Andy, do you have to add something?
No, not really. You could mention runaround coils maybe, then I think you have done everything.
Yes. Another kind of heat recovery systems is runaround coil system. It's a mixture between recuperative heat exchangers and regenerative heat exchangers. This kind of heat exchanger is not able to transfer any moisture between return air and supply air. It's one of the main positive things of this kind of heat recovery systems, that it prevents any transfer from harmful substances from the return air to the supplier. That's why it's often used in special applications like hospitals or laboratories, where any transfer from harmful substances between return air and supply air must be prevented.
Thank you very much. I think that made it very clear going through all the different types of heat exchangers we have.
Yes.
Next question that was asked is, what is the difference between an AC and a ventilation system, which we already briefly elaborated on in the beginning? Andy, maybe you could elaborate on this a bit more even.
Or me?
Yeah, Ralf, you?
Okay, yes. So an AC system, an air conditioning system, primarily serves to cool and to heat rooms with using recirculating air, mostly 100% recirculating air. Typically, no fresh outside air is supplied to the room with these AC systems, so there is no renewal of the room air possible. By that, there is no dilution of pollutants or pathogens possible. The usual very high airspeed to transfer more or less heat or cooling capacity to the rooms means there is a longer dwell time and distribution of aerosols in the room air as a problem. A ventilation system, a so-called air handling unit, supplies the ventilated rooms with fresh air from the outside, and used room air is removed. The cooling and the heating of the rooms can partly be provided by the ventilation system. Sometimes also 100% of cooling and heating capacity, but as a standard, it's only partly a second work from these units. Mostly additional heating and cooling capacity or additional heating or cooling systems are installed in these buildings. Depending on the quality of the outside air, the fresh air supplied by an air handling unit or a ventilation system or ventilation unit is very clean and free of any harmful substances or pathogens. But this depends from the outside air quality.
Mm-hmm. Thank you, Ralf. So to highlight here again, both AC and ventilation, this is essential. And most important is to handle it correctly, because obviously you need to cool the air in many regions of the world. You cannot live without air conditioning, for instance. So look at the combination of both. Another question that is very frequently asked these days, and where we need to also separate a little bit facts from fiction. What is your opinion concerning UV lights in air handling units? Here I pass over to Andy.
Yes, for the difficult question. First of all, if you look UV lights and then in relation with the subject that we have today with COVID-19, up till now, there is no study that proves, but also does not disapproves that any viruses or these viruses are shown in a ventilation system. So in the relation with COVID-19, the UV light, just to add it in a ventilation system, is maybe at least up till now, not proven that it is needed. Of course, UV or UVC lights can be very useful in certain applications where you have viruses, bacteria, or fungus or the possibility to come in your system. And that's especially in, let's say, hospitals where you have a high contamination rate, or in laboratoria where you have those special conditions, or in conditions where fungus grow due to high level of humidity can occur. Then UV lights can be entered in the system. I think you should also always go to real experts, so talk to the experts, the suppliers of these products, where to install them. Position is quite important. What's also quite important, that's the time of the air being in contact with this UV light. So if the airspeed is too high, then the contact time is very low, and then the UV light does not have any effect on the air, or not the desired effect of the air. And in general, a UV light is better to really use very close to the source. That means very close to the room where you expect a possible threat, or even in the room itself where you could use this UV light.
Thank you, Andy. So here again, critically reflect on such questions if they ever reach you before deciding anything, and see, does it make sense for my particular system? As Andy mentioned, in a hospital environment, of course, can make sense, but in another type of environment, it might make no sense at all. So just critically reflect on this. And last question submitted before the webinar is, and often coming up by consultants or planners, should I install HEPA filters in a general ventilation system? Here, Andy, I think it's you again concerning this question.
Filtration for me?
Yeah, Ralph.
Ralph,
Okay.
Feel free.
Morten. So normally fresh air of ventilation systems is outside air is usually free of pollutants and pathogens. As I described, it's depending on the place of installation. But the consultant is selecting the filtration system depending on the outside air quality, using recommendations like the Eurovent recommendation. The filtration, the main task is filtering, or the filtration of dust from the outside air, but also by using activated carbon filters, the filtration of harmful substances. Filtration of viruses from the outside air is basically technically possible, of course, by using HEPA filters with a very high filtration class. But this kind of filters are only recommended to use in buildings like hospitals, not for public buildings. And change of filtration class from a standard ventilation system to an HEPA filtration system or an HEPA filtration class is normally not possible, because you need an additional pre-filtration to reduce the dust load on the HEPA filter, to increase the maintenance time, the change time for this filter. And of course, also the ventilations, the fans are not designed for a high pressure increase necessary to run a ventilation system with HEPA filters. So from our side, there is no need, but also no possibility to change in an installed air handling unit for a public building the filtration class up to HEPA filter.
Thank you, Ralph. So here again, critically reflect on such requests, not jumping on the train immediately. First, see if it's necessary and useful and even possible for your system. So these were the questions before. We have received a lot of questions also in the chat. We'll try to speed up. An hour has passed, so we'll go through the most relevant questions that were asked. Christine, for instance, asked, what if the outdoor air humidity is higher than 60%? Do you recommend a dehumidification system? I think, Ralph, this is something for you.
Yes, of course, because normally the consultant should plan this dehumidification system because it's a part of the air conditioning system, not only to reduce the temperature inside the ventilated and occupied rooms, but also the humidity level in a range not higher than 60% relative humidity because of the problem of a very wet climate is harmful and not for well-being of the people inside the ventilated rooms.
Thank you, Ralph. Next question here coming from Nishit. How is a leakage test done, Richard?
If we are talking about the rotary heat exchangers, it is a part in the Eurovent program, and it's tested with the tracer gas method. They're putting tracer gas in the exhaust air and measure it on the supply side.
Thank you, Richard. Basic question asked, can we receive the presentation? Yes, we will send it to you afterwards, as always, no problem. Then we have a question from Nicolas. I don't know where related to in particular, but what about VOC levels? Who volunteers?
Yeah, I can answer that. VOC is also a method of measuring the quality of the indoor air or the quality of the air. There is a difference between VOC and CO2. In general, CO2 is, with the current measuring systems, always part of a VOC measurement. But VOC stands for volatile organic compounds. So that means it's measuring much more. It's measuring compounds that are very easy accessible in the air. For example, perfume, or it can be if you have a new carpet on in your building, or glue or whatsoever, that are also volatile compounds. So with VOC, you can check if the air is clean, but sometimes it's not the best way to check if a lot of people are present in the building. If you want to check if a lot of people are present in the building and you want to adapt your ventilation rate to that, then it's more easy or better to use the CO2 level, because that's really the result of people being in the room.
Mm-hmm. Thank you, Andy. Another question coming here from Mark Lennon, asking, do you recommend supplying the fresh air directly into the occupied space and avoid connecting to secondary systems such as fan coils and the like? Andy, what do you think?
Oh, this is a very difficult question, at least also for me. I did not really take that into consideration yet. I think at the end, bringing fresh air to the room is most important at the moment. If then that air is treated afterwards in the room by an EC system, or let's say a heater in the duct, or components in the air handling unit to control the temperature, I don't see that as any difference where that component is. So I would not say that, for example, chill beams or an air conditioner in the room connected to a fresh air supply system is negative in this case. But maybe Ralf or Richard or Michael have another opinion.
So at first glance, it's no difference. It's better to use only a part fresh air or than to use the secondary system without any fresh air. So to my mind, there is no difference to use the fresh air directly in the room or over the secondary system. So it's this effect of diluting the room air, the harmful substances in the room air is, as in first idea from my side, the same.
Thank you. A question here from Andreas, another one. Good afternoon. Would you suggest AHUs with runaround heat recovery systems? What are the disadvantages of such a solution? Richard?
Yes, well, it is not that common used maybe because the efficiency is not that high, or it makes the unit quite big if you need to have high efficiency, and it's quite expensive as well. So that is the most negative things about the runaround coil system. And it doesn't transfer humidity, of course.
Thank you, Richard. Then, yeah.
Sorry. So it's not necessary to use under COVID-19 a runaround coil system as in heat recovery. It's necessary for special applications, like in hospitals, for instance, or if you have an old installation with decentralized extract air and supply air, then you can use a runaround coil system and have also a heat recovery system. But for a standard ventilation system, it's not a recommendation to use a runaround coil system.
Thank you. A general comment from Punit. This is a great webinar. Thank you very much, Punit. Appreciate it that you like it. A very specific questions from Dimitris being asked, what about humidity on ceramic heat exchangers on decentralized systems? It's a good one.
Yeah, that was a good one. As far as I know, we don't have these exchangers, but maybe Ralf and Andy knows more about it.
Ceramic heat exchangers.
I think no worries, guys.
No.
So we will look into this again and come back to you here.
Written answer, yes.
Is there then a question asked by Valerio? Is there any rotary heat exchanger that can avoid moisture transfer? For example, in brackets, ST condensation rotor in DV units should make condensation but without any hygroscopic coating. Purge sector should be able to clean the rotor.
Yes, when using this ST rotor, it will be condensation during cold climate, as Ralf described before. So you cannot avoid moisture transfer all the year. That is the short answer. Yeah.
Okay, thank you for this, Richard. Then Michael Stelios asks, what is the recommended airspeed in AHUs using UVC light in relation with the contact time needed? We are getting more scientific here.
Yeah, at least I think then I speak for all of us. UV lights, I think then you really have to go to the supplier of the UV light. I think that contact time differs per system. Of course, the intensity of the light that goes into the system, but maybe it also differs in what do you want to prevent or kill with this UV light. And then I would really recommend to go to the expert rather than ask to the supplier of the total system.
Yeah. Thank you, Andy. And then a question from Okan that is often being asked: should fan coil units be working during the pandemic? What are your recommendations concerning fan coil units? This I would like to answer. Here, please follow all the recommendations that were published by organizations such as ASHRAE and RAVA. There is no need to turn your fan coil units off. Everything is described in there in detail. And why is this? That's all we can say in this respect. Then Nicholas asked, what about particulate matters? PM 2.5 and PM 10. It's a good question. In which context? In general, Andy, what would you say here concerning the filter selection? This would be described also in Eurovent 423.
Yes, it's a part of the Eurovent recommendations, depending on the outside air quality, the place of installation, which filtration is necessary to reach the demanded, the required indoor air quality. Mm-hmm. This is depending on the PM classes or the PM fraction inside the outside air.
So the Eurovent 423 recommendation, for your information, it shows you a common type, let's say, of outdoor environment, for instance, nature in Sweden or a big city like Milan, and then recommends you a certain type of filter. And if you look at this recommendation, that should be very helpful for you in this respect. It is, in fact, a very helpful tool. A question from Serkan being asked: what do you think of electrical air cleaners? General question here. Some people think it's useful against viruses. Additionally, do you think that filtration on the exhaust side of the AHU is necessary? Maybe the last question first.
Or the first one. So I think you mean with electrical air cleaners, small recirculation units with a high filtration class, not a product from Systemair, but we know that they are using HEPA filters. And if this electrical air cleaner is a unit like this with an HEPA filter, then of course this is helpful to reduce the harmful substances or pathogens inside the room air. So it's better than nothing. But only if the filtration class of this air cleaner is high enough. But as I know, or as we know, this is normally in a HEPA filtration class. Mm-hmm. And
thank you.
Additional filtration in the exhaust air, it's normally not necessary. Also under the influence of COVID-19.
Thank you. Again, here also concerning air cleaners and filters, it always depends which type of air cleaner and air cleaners. There are good ones, there are bad ones, and they don't replace ventilation. So they should not be seen as a substitute in this respect. Yes. Again, a question here from Serhard concerning UVC lamps. Is there an academic study concerning UVC lamps? I think we can just repeat what we said before. Critically reflect on it, ask your supplier, see whether it makes sense for your system, and don't jump on the train immediately if it makes no sense. So here, separate the facts from fiction. And the topic is evolving, so we'll keep you posted once we have some more information concerning this issue. Okay, then we have again similar questions that were already asked. A question from Ioannis. In an HU with rotary heat air exchanger, the rotation should be stopped, and if possible, the air should be discarded without passing through the exchanger. In HU with plate heat exchangers should be switched off if possible. It seems to be a statement here. I think we have learned also now in this webinar from our experts that this cannot be put like this.
The next question is to this.
The above guidelines are given by the government in order to prevent the exhaust stream of air to transfer aerosol viruses particles to the supply stream of air. What is your recommendation?
Well, the recommendations for the rotor is to keep it running as being discussed during this presentation. That's the short answer. Yes.
Yeah, I think it also depends where you are. If you are, let's say, in a very critical room, in an intensive care room of the hospital, where you have high condensation of viruses or possible threats, that should be considered differently than general applications. And for general applications, it's much more important to get fresh air in than and then accept a small part of leakages and maintain the very good relative humidity than to stop systems to ensure that people are well in that building. But again, if it's a very specialized area, then of course maybe other recommendations are applicable.
Thank you very much. A lot of questions, could even answer even more, but these were the most important one, and we'll leave it with this today. We have a good input from you, and we'll try to answer them also after this webinar and consider them for future case studies and recommendations. Thanks a lot for all your input. I like to quote Hakan here, who wrote, "Thank you all and stay healthy." We're wishing you all the same. So as a final slide here to be continued, how can I learn more? What can I practically do? So of course, the presentation slides will be made available to you after this webinar. More studies, case studies are offered on our website. You'll find them directly on the front page when you go to systemair.com or to your local Systemair page. At any time, connect with us on LinkedIn. On LinkedIn, we provide the most up-to-date information in real time. And feel free to reach out to our local offices. You know, Systemair is represented across the world, so there will always be a Systemair office near you. And after all of this, remember looking at the picture on the right, let's all together strengthen ventilation and focus on the V in HVAC. Why? Because it's more essential than ever, and correct ventilation is a key these days. With this in mind, thank you for attending, connect with us, and hope you had a useful and productive webinar. Regards to all of you across the world. Thank you.